In this section, 7.4, we're looking at our special right triangles. When we say special right triangles, we're talking about our 45, 45, 90, and 30, 60, 90 triangle. So let's get started. First off, we have our theorem on the 45, 45, 90 triangle. That tells us in a 45, 45, 90 triangle, the hypotenuse is radical 2, or root 2, times as long as each leg. So, first off, we talk about 45, 45, 90. We're saying it's a 45 degree, 45 degree, 90 degree triangle. These will all work the same way. The first thing we know about these triangles are the legs are the same, which hopefully we know that means it is isosceles. Which is nice because we know if whatever value of that leg, it will be the same for the other. Now, we also, what we're saying here is the hypotenuse is root 2 times as long as each leg, or the hypotenuse equals root 2 times the leg. Now, what we're going to do, let's label this triangle and say that the two legs have a value of a. And if that's the case, I would say, well, radical 2 times a gives us the hypotenuse, which would be a root 2. Now, this gives us a nice relationship to go by when we're talking about these triangles. Now, it doesn't matter what size a is, the hypotenuse will always be a root 2. It doesn't matter what the hypotenuse is, we'd always divide or get rid of the root 2 to get to the leg. So let's just kind of sum up and kind of give us a direction of where we're going to go. Let's say we know the hypotenuse. And you want to find the leg. How are we going to get from the hypotenuse to the leg? So right now we're at this a root 2 and we want to go to the leg. Really either one, doesn't matter. Well, if I'm here and I want to go here, I have a root 2 and I just want a by itself, I'm going to divide by root 2. Let's say I know the opposite direction. Let's say I know the leg and I want the hypotenuse. So I'm here and I want the hypotenuse. Or here and I want the hypotenuse. In that case, I'm going to multiply by root 2. Notice how they're the opposites of each other. I'm either dividing or multiplying by root 2. Hypotenuse to leg, divide. Leg to hypotenuse, I multiply. Well, let's try that out on a few basic ones. So, let's label them as we get practice with them. So a root 2. I'm at the leg. The leg is 8. I want the hypotenuse. I'm at the leg to the hypotenuse, I multiply. So it becomes 8 root 2. Let's look at the next one. This is a root 2. So I'm going from a to a root 2. I have to multiply. That's going to be 3 root 2 times root 2, or 3 times the square root of 4, which is 3 times 2, or 6. Okay, next one. I have 5 root 2. That's my hypotenuse, and I want to go to the leg. So I'm going to divide by root 2. So I'm going to take 5 root 2 divided by root 2. Those simplify, and it becomes just 5. And maybe you saw that. Really, that's the difference between those when there's a root 2 there. We multiply from the leg to the hypotenuse. We divide from the hypotenuse to the leg. Okay, let's try a couple more. I'm at the hypotenuse. I want to go to the leg. I'm at a root 2. I want to go to a. I have to divide by root 2. If I divide, I get 2, which is the legs, or x. Next one, I'm at the leg, and I want the hypotenuse. A to a root 2. Looks like I have to multiply by root 2. I have to get that root 2 into the number. So it's going to be root 2 times root 2, which equals the square root of 4, which comes out to be 2. This one, it's a square with has a diagonal D, but really that's just a right triangle. So I have A root 2. I go from A to A root 2. I multiply, so it's going to be 8 times root 2, or just say 8 radical 2. And that's D. Hopefully these are catching on. That's going to be good. Okay. Now let's take this idea of these special right triangles and try to apply it to where we're going to see it later. So now we have a square. Let's mark our square. We know 4 right angles. All the sides are the same. And the diagonal is 8 centimeters. So we need to find the length of the side, any of the sides, because we know they're the same, and then the area of the square. Well, this is really a 45, 45, 90 with 8 on the hypotenuse. So I'm at A root 2. I go to A. So think, what am I going to do with that 8? I'm a hypotenuse to leg. I'm going to divide by root 2. Now, we've reached a point here, we can't leave it like that. We can't leave a radical in the bottom. It's not good form. So I have to simplify this out. The way I'm going to simplify is I'm going to multiply the top and the bottom by that radical. Because when I multiply it, I'm really just multiplying this by 1. That's really all root 2 over root 2 is. But when I multiply this, I get 8 root 2 over square root of 4, which is 8 square root of 2, or 8 root 2, over 2, which simplifies to be 4 root 2, which is simplified. There's no radical in the denominator, and I can use that as my side length. Okay, now though, they want the area of the square. The area of a square is the side length squared, or 4 root 2 squared. That's going to be square the first number, and then square root of 2 squared is just the 2 kind of cancel each other out. I get 16 times 2, or 32 as the area. So the side length was 4 root 2 because we had to simplify the radical. Then the area, we plug that in and square it, and we get 32. Now that's some good practice with the 45, 45, 90. Let's now look at our 30, 60, 90. So in our 30, 60, 90, the hypotenuse is twice as long as the shorter leg. Let's start with that. Hypotenuse is twice as long as the shorter leg, so that's 2 times the shorter leg. And the longer leg is radical 3 times as long as the shorter leg. So the longer leg is root 3 times the shorter leg. Okay, so before we use that rule, let's kind of apply the same way we did before. Now, first off, I need a rule that always helps me make sure I pick the correct shorter leg. Back when we talked about the inequalities, the shorter leg is opposite the smallest angle. What's the smallest angle in this? Well, it's a 30, 60, 90, so it's opposite the 30 degrees. So that's the short leg. This is the longer, and this is the hypotenuse. Okay, so we have the hypotenuse is 2 times the shorter, longer leg is root 3 times the shorter. Let's use that same approach we had with A. A is going to be our shorter leg. If A is our shorter leg, the hypotenuse is twice that, that'd be 2A. If A is our shorter leg and the longer leg is radical 3, or root 3 times that, it would be A root 3. So that gives us the guide the same way we can kind of take that template and apply it to any 30, 60, 90 problem. We double it to get the hypotenuse, multiply by root 3 to get the longer leg. Now let's go through that list again for what we did, for what we have and what we want. And that maybe gets us used to dealing with this. So let's say you have and you want. So let's say you have the short leg and you want the hypotenuse. So I went from A to 2A. Well, what do I have to do? I have to multiply by 2. Let's do the opposite of that. Let's say we have the hypotenuse and we want the short leg. So that means I'm at 2a. I go back to a. To get from 2a to a, I have to divide by 2, or just do the opposite. Okay, let's say I'm at the short leg, and I want the long leg. I'm at a. I want to go to a radical 3, or a root 3, so it's multiply by root 3. We'll do the opposite, the long leg to the short leg. So I'm at a root 3. I want to go to a. I need to get rid of the root 3, so I'm going to divide by root 3. So what do we got left? It looks like longer leg to hypotenuse. So let's first say we're at the hypotenuse, and we want to go to the long leg. Now, do we have a rule that lets us jump from here to here? We haven't yet. It all goes back to the shorter leg. So we have the hypotenuse. We want the longer leg. We're going to go in this direction. So first thing we have to do is go to the short leg. And then we're going to go to the long leg. So hypotenuse to short leg, we divide by 2. Short leg to longer leg, we multiply by root 3. So it's 2 steps. It's not that we have one clean operation for it. We could have one. We could remember that. But if we keep the steps down, then it works for us. Then last, let's say we want to go from the long leg to the hypotenuse, and we have to go through the short leg again. So long leg to short leg, a root 3 to a, I divide by root 3. And then shorter leg to hypotenuse, like we said up here, I multiply by 2. So that gives me the guide to go by. As you go through these examples, maybe this is a good thing to have along with this, so it's just something to reference as we go. So let's look at those examples. All right, so we look at it. We need to first, we're just finding one variable at a time. So I'm at I'm at radical 3, root 3. I need x. Let's first make sure we identify this 30 means this is the short leg. This is opposite the 60, so it's the long leg. So I'm going from short to long leg. Now, we look back at our list, and when we did that, we multiplied by root 3. So I'm going to do that. I'm going to take root 3 times root 3. That gives me square root of 9, or 3 for x. Look at our next one. Okay, well, I'm at the long leg. I need the short, and I need the hypotenuse. Well, we can only go from long to short first. So if I go from long to short leg, I'm going to divide by root 3. So 9 over root 3. Now this is where we have to simplify it because we can't leave it as a radical. So we're going to do root 3 over root 3. That gives us 9 root 3 over 3, or 3 root 3. So that's x. Okay, and now we're going to finish up and go from the shorter leg to the hypotenuse, which we said earlier was just multiplying by 2 because it's double. So 3 root 3 times 2 gives us 6 root 3 for y. Okay, now we can't jump from long to hypotenuse. We just have to go through each step, which we did, and it worked for us. Okay, let's do a couple more examples. Okay, find the value of the variables, write it in simplified radical form. So now this time, it looks like we're going from short leg to long and hypotenuse. And we have to be careful because if you notice on the last one we looked at, 9 was the one we started with, but that was the longer leg in this case. We have to pay attention, it's the shorter leg this time, and be careful with the steps we go. So if I go shorter leg to longer leg, I multiply by radical 3, so it's 9 root 3. If I go from shorter leg to hypotenuse, we said earlier we multiply by 2, so it would be 9 times 2, or 18. Hypotenuse is 18, longer leg is 9 root 3. Okay, next one we're going from longer leg to shorter leg, and then eventually the hypotenuse. To go from longer leg to shorter leg, I have to divide by root 3. If I take 3 root 3 and divide by root 3, that comes out to be 3. So that's x. And now to go from x, or my shorter leg, 3, to hypotenuse, we double that. So that means y is going to be 2 times 3, or 6. So hypotenuse is 6, shorter leg is 3. Last set here, I'm going to start at the hypotenuse. I'm going to go to the shorter leg, and then finish at the longer leg. So from hypotenuse to shorter leg, we said earlier we have to divide by 2. So that's going to be 12 root 3 over 2, or 6 root 3. Let's fit it down here. Once I have that, I'm going to go from shorter leg to longer leg, and the way we do that is to multiply by root 3. So I'm going to take 6 root 3 times root 3. That gives me 6 times the square root of 9, or 6 times 3, which is 18. So shorter leg is 6 root 3, longer leg is 18. Okay, now again, we're going to apply this to some triangles. A little bit different way. So we have an equilateral triangle with side lengths 6. They want to know the height of the triangle. Now, what we know about an equilateral is it's also equiangular. So this is 60, this is 60, and this would be 60 up here, but we split it, so we're not going to mark that yet. But we know the height has to be perpendicular to the base, so that gives us two triangles, that if we kind of look at one of those, we have 6, we have a 90 degree there, 60 degrees there. Well, what would the other angle be? Well, 90 and 60 is 150, minus from 180 we get 30 degrees there. It turned into a 30, 60, 90. So now we can solve it as we go through. This is the hypotenuse. We need the shorter leg. Well, we said earlier the shorter leg is half the hypotenuse, so that's 3. Then to get from the shorter leg to the longer leg, we said we had to multiply by root 3. So for the longer leg, which is really our height, it's going to be 3 times root 3, or simply 3 root 3. So in that triangle, 3 root 3 would be the height of it. Okay, now here's some practice problems. What I would recommend, maybe if you're doing these as you're getting ready for your homework or doing your notes, why don't you pause the video, try these, and then we'll go through, check our answers, and you can see how you did. Now, as we go through, we have to make sure we separate between 45, 45, 90, 30, 60, 90. Start off with our first one. 45 there, that means this one's also 45. First thing we know about a 45, 45, 90 is it is isosceles. So x is 7. That's the other leg. And then if we go from leg to hypotenuse, we need to multiply by root 2. So that means y would be 7 root 2. Next up, we have 60, 90. That means this is 30. Our shortest side is G. So to go from our hypotenuse to our shorter side, shorter leg, I need to divide by 2. So that's 9. And then to go from the shorter leg to the longer leg, I have to multiply by root 3. So that'd be 9 root 3. Next one, I have 45, 90. This is also 45. My hypotenuse is 9 root 2. I need each of my legs, A and B. They are the same because it is isosceles. So 9 root 2 divided by root 2 gives us just 9 for both of those. Next one down here, I have 30, 90. This is 60. My shortest side is 5. To get to my hypotenuse, I multiply by 2 to get 10. To get to my longer leg, I multiply by root 3 and get 5 root 3. Next one, 45, 45, 90. My hypotenuse to my leg, I have to divide by root 2. Well, 15 over root 2, I have to simplify. So I do times root 2 over root 2. That becomes 15 root 2 over 2. I can't simplify it. 15 is not divisible by 2, so we're just going to leave s and t as 15 root 2 over 2. Last one we have here, it's a 30, 60, 90. We have the longer leg. To go to hypotenuse, or not the hypotenuse, the shorter leg, I divide by root 3, and that becomes 10. To then go to hypotenuse, I multiply by 2, so that would be